What the challenge was that was being offered to Danny is that if you had an infinite series, necessarily, right, every permutation would occur. That's what Danny
Right.
is contesting, right?
I
And the
understand that.
way he's contesting
Simos,
it,
I understand, Jack. You don't need to
is
repeat.
by the way he's contesting it.
We know.
How much you want to bet that I need to repeat it, right? You think people are going to get this?
Yeah, Jack, you
Okay?
need to be
So
quiet now, dude.
so
No, no.
This
Let's
is
so
let Jack
ridiculous.
talk.
so all Danny is saying
Oh
is
my
if
God.
that's the case, right, that it's necessary, then that should entail that there be a logical contradiction in a set that is infinite and doesn't contain every permutation, right?
We get it.
Now,
Simos.
just a minute.
Oh,
Now that I've
Jack.
repeated it, now that I've
I'm just waiting
repeated
for
it,
my turn.
now that
Simos goes next.
how much do you want to bet that people don't still understand it,
Okay,
right? Even
so
though I've
Simos, what I
repeated
wanted
it.
to ask you is, um, could it be? Are you saying that, in fact, there is a contradiction?
Uh, to what? Sorry. I mean, I needed Jack to just carry. I'm sorry to, say this, but I needed Jack just to finish off what he was saying.
Shit, I'm so sorry,
It's okay. It's okay.
Jack. Would you mind repeating?
No.
Yeah, I'll
Oh shit,
repeat it.
Jack was
I'll
right.
repeat it, and I'm going to tell you, no matter how many times I repeat,
Just get to the end part again, Jack, for me.
Simon is not going to agree, no matter how many times I repeat it, right? Okay, so here it is, right? Danny was saying, right, that there's no contradiction entailed by there being an infinite set that's an ordered series, which is to say, an infinite set that doesn't contain every possible permutation, right? And that's
Correct.
precisely what Floyd was challenging. He was saying that if there's an infinite set, right, if there's an infinite series, right, necessarily every permutation will appear, right? And Danny's response to that was to say, well, there's no contradiction entailed by having an infinite series in which, let's say, an infinite series of coin flips in which every coin flip comes up heads,
Yes.
right? That
Okay,
doesn't
so
contain a
Simon, the question
contradiction,
is,
right? So the
do
question
you
is,
think there is a contradiction, or do you agree there is no contradiction?
Yeah. Okay. So, okay, I think I know what you're saying, Jack. And my point there would be that what you're pointing at is not something which could be. What you're not talking to a finite series within an infinity. You're talking about an infinite series within an
Oh
infinity.
my God.
yeah, see,
I think, and I
Helena,
think that. Oh, do you want to let me finish? Yeah.
Yes,
And I
please.
think that it's not a contradiction to say that an infinite series can happen within an infinity for a start. That's number one. So
I'm
if that addresses your issue, I
What?
think you probably go.
I'm starting to think there's a
Oh, that's
contradiction.
very
I'm starting to think
interesting.
that there's a contradiction in saying that I can successfully
Well,
explain this to you.
infinity doesn't have a sign. Right? It's not a cardinal number.
Okay, well now I'm gonna
Right?
take a quick
So
turn. Okay,
when
look, he
we
gave
talk
the
about
example of the blue shirts thing. Just dude,
hang on,
please, please.
hang on. When we talk about infinities, right, we're not talking about
Oh fuck.
cardinal numbers. When we're talking about probabilities, we are talking about cardinal numbers. So there is no contradiction, as far as I can see, by saying that all probabilities will
That's what I was gonna ask you
all
actually. Are we
probabilities
talking
Will you
about
let him say
abstract?
what there's no contradiction in?
will occur within an infinity. I don't see that as any contradiction.
An infinity of what?
Okay, but couldn't it be that there's no contradiction
Okay,
either way
I'm
you
gonna
look at
fucking
it?
take a turn, all right?
Yeah,
Either you're
I
talking
don't see
about
what
an abstract series or you're talking about a physical system. Which one?
we're talking about. An physical system within an
Oh,
Oh
physical
infinity.
fuck.
system. Great. Okay, a physical system. Great. All right, good. So within a physical system,
Hey,
you've got an initial condition of the system, right? Yes or no? Or are we talking about like an acausal physical system?
we were talking about coin flips.
Okay, Helena, we'll talk about this privately where there's not like an arena.
Okay, but I want to hear from Simos because it sounds like he's going to say you can look at it either way, and there's no contradiction in either way. And I
Yeah,
just
so
want to
let
double
me
check
just
if
ask
he
a quick
agrees with
question.
that.
We'll use the t-shirt example that
Uh,
Danny has given, okay? Now, if you're saying that within a physical system that is even this actually applies to an abstract thing with the t-shirt thing, but look, in a physical system, right? Can you simultaneously have a universe with an infinite series of wearing blue shirts and a series where he wore blue shirts every single time except one? Can those both simultaneously be true?
I think those can both simultaneously be true, but you could not know it.
How?
But you could
How?
not know it.
You couldn't know it because it goes on forever, or what? Why couldn't you know it?
It goes on forever. And you
Yeah,
can't-
that makes sense. I
Yeah,
understand.
How can
but
you
no,
have
now you're
an
talking about a
infinite series of
computability
wearing
problem.
blue shirts when
Well,
you
he-
wore a red shirt once?
Yeah, you're talking about a computability problem on an
Jeez.
infinite set, right? Like you can't compute an infinite set. But we're talking like this is, computable infinities don't actually exist. Okay, there's going to be some finite amount of energy and matter available for computation
Okay,
as we understand it.
I
I
have to
don't agree
go.
with
I
that,
have to
but-
go. I just want to say that JJ gets the gold star here. JJ,
Explained it so that you could see it
Cares about
both
both sides.
ways. Bag should get some freaking credit for that, Mr.
Given
Danny.
an infinite number of opportunities, even JJ can get a gold star.
All right, Danny. Yeah, we're just run away. Run away, Danny.
I mean, look, dude, I understand what you're saying about if it's an infinite set, you can't know epistemically what the actual probabilities of something are, right? Under computability. But if we're
well,
talking
babe,
about an
you
abstract
explained it
category-
well. We're talking about. I think we moved on to a different subject. You changed the subject, which is fine. Which is
Well,
fine.
well, the
Back, that's
irreversibility thing
wait,
that I
almost
mentioned
done. Almost
before,
done.
yeah,
Almost done.
is a
Almost done.
problem.
Almost done. Almost done. Yeah, that's fine. We can change the subject, but you did get it right before, like about
I
5
know.
minutes or 10 minutes ago. Okay. So, but at this point, I think you're changing the subject as to the differentiate between mathematical infinites and like actual infinites or something, right? But I'm not.
Oh,
I'm
yeah.
not. Yeah, I'm out.
I think this is just an effort to try to understand what Simon is trying to say.
I think that's the conflation Danny made, to be honest.
Oh, fuck.
Listen,
I
dude, there are
so-
like to go back to what Danny just said I was right on, which you didn't answer to because everybody started piling on. In a physical system, there are going to be states of the system where the probability of some outcome is nullified by choices that are made in that physical system. So how do you reconcile that there are an infinite probability of events for any given arbitrary event when within a modeled physical system, those events are going to become improbable by choices made in the system from the initial condition onwards?
Who are you talking to? Me?
Yeah, I'm talking to you.
Yeah, okay. Well, whether it lands heads or tails is not an infinite
We're not talking about heads or
probability.
fucking tails. We're talking about a physical system.
I was talking about heads or tails, so again.
Okay,
let's-
well, I'm not fucking talking about heads or tails, buddy. I'm talking about an actual
Babe,
physical
come
system.
on.
Okay, then I don't know what you're addressing me with. What ask your
I'm
question
addressing
again?
you with the claim that if you have okay, let's just get this. Okay, let's suppose that we have a physical universe that is infinite. All right. Now, this can be something like there is a heat death of the universe, and it just persists infinitely as nothingness after some point. All right. Is that infinite?
Sorry, you cut out for me.
If we have a physical system that includes something like a heat death at some point, right? Can that be said to still be an infinite system? Right? It goes on after some point, and there's no probability of any action taking place, but that universe is still infinite. Yes or no?
I don't know.
You don't know. Why not?
Well, because I don't know whether the universe is headed towards an infinite.
Okay, well, can we just suppose that it is? Can we make that supposition? Can you imagine a universe in which it's the case that the universe exists, although no probable actions are possible?
Sure, but in that case, put it forward as a hypothetical, not asking.
Yeah, a hypothetical, right? A hypothetical universe, right? So here we go, right?
Don't ask me whether I think it's true or not.
Yeah, well, all infinities are hypothetical, buddy.
You're talking about true inside
Today's
of
video
the
is
hypothetical, dude. How do you not know this? And if you don't understand what a hypothetical is, why are you in these arguments?
So
You didn't
we've
say
just
it was
come up hold on, we've just come up with a model, right, which you've agreed to, that we can have a universe that exists infinitely, but at some point it reaches something like a heat death where no probable actions can occur. It's impossible for things to happen because there's no ability for anything within the universe to interact with any other thing. Okay? Zero probability of any outcome occurring, but the universe exists. Do you agree?
What? That's a hypothetical. Okay, yes,
Yeah,
hypothetical.
so it's an infinite universe, right? This is an infinite universe, but we don't have the ability to have infinite outcomes because there exists a heat death. Now, not only do we not have the ability,
No,
right?
no, it could be that after a heat death, the unit energy is still remaining, and that causes another universe, right? Still the same series of events, just another universe occurs.
Okay, so you're with me that there
Lost
exists
in the weeds.
there exists an infinite universe that includes a heat death,
No,
where after
I agree, it's a possibility.
okay, that's all I'm asking is for you
Oh my
to at
goodness.
least caveat with the case that you can have an infinite universe where you don't have this infinite outcome of series, right? Every probable outcome, okay? Because if you have a universe that exists and is infinite but includes a heat death, then there's going to be some finite permutations possible within the physical system before the heat death of the universe.
Yeah, in between the universes that happen out in between the heat
Oh,
death.
now you're supposing multiple worlds, which we already caveated is the case.
If you're allowed your
That's not.
hypothetical, then so am I. All right, now it
That's
could
not
be
many worlds though.
after a heat death, the energy still remains and it causes another universe. That's a possibility.
Yeah, but
Well,
we're
there would be a
same.
heat death if the energy still
That's,
remains.
that's the same universe.
Exactly. That's a possibility.
What?
well, how is it a possibility if it's reached a true heat death?
Yeah, okay, so what do you mean by heat death?
I mean, a
Oh
heat death,
my
as far
God.
as we understand it, especially in this hypothetical, is that matter and energy has become so sparse that it can't even interact. Like even the weakest force, gravity, will never reach any other particle.
Okay.
That's not possible.
That's
No,
a
it's
true
quite
heat
possible.
death.
Space expands it. And
That's-
It basically means that the universe has reached the minimal energy point. There's no possible way that anything can interact with each other or cause outcomes.
Yeah, sorry, what's the point of your hypothetical? I'm kind of
That
struggling
this
to
is
see.
a model of an infinite system where you don't have infinite probability of equal outcomes.
It's not an infinite system if there is in fact a heat death, like you
Why wouldn't it
described.
be? I mean,
It
the
would be an
universe still
infinite system
exists.
because it persists infinitely. It just wouldn't interact infinitely.
Right. So again, I've tried to see what the point of what my argument was to this anyway. But so
Well,
I
his
you-
point is that you eventually would stop flipping a coin if you lost the heat density to have physical motion or exist
right, okay.
as
So,
a physical object.
but then
It's terrible.
we wouldn't then be talking about an infinite series of coin tosses, would we?
Sure, you would. It's a universe. It exists. It's a thing. It does exist. It's a set. It becomes an empty set at that point.
Right now.
Yeah. It has become null. It's a categorical bottom. If you're a mathematician, you know anything about categories. It's the bottom. You've reached the bottom of the category. There's nothing left. There's no more outcomes. The category exists. It persists infinitely. It's an abstract, right?
Hmm?
Okay.
Sure.
So there we go. There's an infinity wherein you cannot have any additional outcomes, and so there is a within an infinite universe, right? It persists infinitely,
Right.
but you still don't have an infinite variety of outcomes.
Okay, so are you just saying that within an infinity can exist? Because I would agree with that.
Yeah, I mean, for one, just supposing that there exist true infinities is nonsensical. It's completely incoherent to say that there is computable
I
infinities.
disagree.
I didn't
Computable.
I did say that.
Well, if the universe is physical, then it's computable. You have the ability to compute in a physical universe.
Yeah, I
Sure.
mean,
Well,
again, I think we're stepping quite far away from what I was saying
So,
about
like,
infinity.
Well, that's
but-
because what you were
Can I just
saying is
hold on? Let's
stupid,
just
and we're
sync
very
this
far away
back
from
on.
stupid now.
Well, hold on. But so I understood Danny's point, Simon, right? And is this just a confusion between like something being philosophical and you talking about like the physics of this? Because I've just looked up the terms that you were talking about, and everything seems to relate to these zero probability events, right? So they have zero probability, but they are possible. And of what I'm reading is that these things are completely counterintuitive. They seem like they're a paradox of sorts, and seem to be a contradiction. Yet the math seems to support it. Is this just some sort of? Is it just someone's arguing physics versus like philosophy? Is there some? Is that what the confusion is, or?
Well,
'Cause
Ren,
I
I
understood
already
Danny's
said,
point,
are we
Simon.
talking about abstract systems? If we're talking about abstract infinite series, then what he's saying is true. But if we're talking about a physical universe, it's not true.
Well,
It
see, I
can't be true.
understood Danny's point, right? But I don't understand what I've looked up. I don't understand the physics of it. I don't understand the math. So I can't get my head around what the problem is in what Danny's saying.
Well, is this all derived from the shirt argument that you guys are making at the start? Because I think I can clarify if that's what you're still discussing.
If we could let Simon go first and then Claire, that would be really good for me because I'm holding
Simon.
Ray's question in my head.
Okay, so yes, I think that is the issue that Danny was saying that you know this is a physical nonsensical, it's nonsensical physically, which is the case. I believe that to be the case. I can't prove that's the case, but I believe it to be the case. But nonetheless, I was literally talking mathematically, literally talking about a definition of infinity, which necessitates probability being necessary. Okay, I mean, I don't. Maybe that's not the correct way to word it. It's getting quite late here, and my voice is going. But
Yeah, well, the case that I gave you of like if you have, and even if we're talking about math, right, pure math, right, and we're talking about some probabilistic outcome, that is that in this infinite series, we can say that there exists an unbroken set of wearing a blue shirt to the gym. Okay, so let's just say that that's the case. Now, to say that there simultaneously exists a set of permutations where Danny wore a red shirt one single time, that would make it logically impossible for there to be an infinite set of blue shirt and a set of all blue shirt and one red shirt choice.
right, okay, so in an infinite set, is there an infinite number of even and odd numbers simultaneously?
Yeah.
Okay, so that seems a contradiction, right?
No, it doesn't seem a contradiction.
Why?
Does it seem a contradiction? Was that the question?
Why would it seem a contradiction? Like having odd numbers doesn't nullify the existence of even numbers. Whereas if you have a set that is defined as an infinite number of choices on wearing blue shirts, the single existence of a non-blue shirt choice would nullify the existence of an unbroken chain of blue shirt choices. It's not like that with an infinite series of odd and even numbers.
Right. So to bring it back to the math analogy, this is like saying there's an infinite chain of even numbers, and can that coexist in the same chain with an infinite chain of even numbers with one odd number? And the answer would be no.
The answer is yes, of
Yeah,
course.
could you let Simon explain what he's
Well,
trying to say, please?
So we have one series of numbers, right? Half of which are odd and half of which are even. Okay.
That's not the analogy.
And yet both of them are an infinite series within themselves.
What?
And so what?
Wait, what?
Well, it seems like a contradiction, but it's not.
How does it seem like a contradiction?
Because what? Okay, you have one series of infinite numbers, correct?
Yeah.
Okay.
I understand what you're getting at. You're basically
I
you're
don't.
thinking of
I don't. Could you let him get to
Let me
it?
explain what he's saying then, because he can't do it. Okay, maybe it's
Just
very
let
late
him
where he
get
is.
to it.
JJ, shut up. So what he's basically saying is like if you're counting, right? If you're literally counting numbers off one by one, then it wouldn't make sense that when you've counted that even, right? That the odd behind it is also infinite, right? Like you're always going to be stepwise, either having more odds or more evens. But that's a fucking retarded way to look at it, because these two things exist in a series, an infinite series, simultaneously, and that is not contradictory. It's not contradictory to have an infinite.
You couldn't possibly be
series.
saying that.
I
You
didn't
could
say
not
that
possibly be saying that.
it's contradictory. I said it seems contradictory.
But it isn't.
Fuck.
But it
Right,
isn't.
that's not contradictory. But what is contradictory is an infinite number of blue shirts being worn by the same person being compatible with an infinite number of shirts being worn by the same person plus one red shirt. because then it would no longer be an infinite number of red shirts being worn by that one person.
Or blue
It
shirts,
would be
right.
an infinite number of blue shirts worn by that one person minus one, because that one would be red.
Which would make it a finite set.
Right. It'd be infinity minus one, which is a finite set.
Which wouldn't be infinite and is therefore excluded.
Right, which wouldn't qualify. That's correct. And so
That's
what
his
Danny
point.
is saying, yeah, what Danny is saying is that you can have an infinite series of one type of thing that its existence alone nullifies that something contraindicated to it could exist. So your example of even and odd numbers wouldn't qualify as analogous to that, because you can have an infinite series of just this stepwise calculation of even and odd infinitely, because
Right,
the existence of odds doesn't make the existence of evens incompatible. Now, if you said,
1 second. Hey,
Likewise, you can't have any.
can I bring this around to a conclusion?
Cannot happen.
So
Blue shirt forms to the
the
ship.
compatibility between the two comparisons.
you're completely roboting for me.
You're
Nobody
breaking
can
up.
hear you, Claire.
Claire, you gotta
Nobody can hear
refresh.
you.
Yeah, and for the same reason, you can't have an infinite number of blue shirts form to the gym.
So your example of flipping coin, I'm not even sure why this discussion was had.
Okay, so I'm going to
Danny
speak now.
said that there was
I'm
an
going to speak
objection
now.
to by Floyd.
I'm taking the
Is
talking
that what
stick.
happened?
I'm taking the talking stick. So Simon, the problem with you comparing your even and odd set of infinity to the blue and red shirt paradox is that they're not the same analogy. What would be analogous would be to say that can you have an infinite set of evens that remains in an infinite set of evens with one odd number inside of it, not just an infinite set of numbers that happen to be both even and odd because that's how numbers work. If you were to make the second analogy, the one I just proposed, then they would be analogous to the blue and red shirt problem, and at that point it would be contradictory. You're just making a bad analogy, and that's what's confusing you.
I think it's a bad analogy to say you can only wear blue shirts. I mean, that doesn't seem right.
Well, that's irrelevant and nonsensical.
Oh my
You're just
God.
lost in the weeds.
It has to have the possibility to wear red shirts in this example.
No, because then it's not an infinite chain of blue shirts.
In order for it to be an analogy with the flipping of coins.
Well, we're talking about blue shirts. You're the one that brought in the flipping a coin thing.
Well, yeah, that's his original example was flipping a coin, right?
Okay, so
What you were
then
saying
I'm
was-
That's what I
misunderstanding
said,
happened.
that the analogy
if
doesn't
you
work
flip
if
a
you're going to
coin-
say it ahead of time that it's always red shirts.
So, Simon, you said if you flipped a coin an infinite number of times, all permutations would. Simon? He left?
I think he said yes. Okay.
Yes.
Oh, there he is. He said yes.
Right. Except the permutation where they're all twos, all ones, and all tails. Right?
No, because you can never reach that permutation. Can you hear me now?
So, if you flip a coin an infinite number of times, all permutations will occur of series, like 3 heads in a row, 4 heads in a row, 2 heads.
I think he's trying to reconnect.
He's back again.
He's going to say, oh, go ahead.
No, your first question, JJ. Probably yes to the second one, which I didn't hear.
So, right. So, flip a coin number of times. Permutations of 3 heads in a row, 3 tails in a row, 2 heads, 150 tails, and 4 ones, etc. Right? That's what you're saying, right?
Indeed, yeah.
Right. So the only things that are going to be in its set are the series that are all ones or all heads.
Yeah, if you think that an infinity is a finite series, then obviously you can never know whether they're all one. I mean, that's the only way I should say that you could know that they'd be all one.
Anything to do with anything.
Well, because you're saying that, oh, hang on, here's an infinite set which is all ones. I'm saying, well, you could never know that.
Simon's saying that there is no
What
all.
does that have to do with anything?
Well, Simon's saying that there is no all, aren't you?
Correct.
In an infinite set, there's no
concept,
all?
the concept of you saying all just isn't can't relate to this.
You're
There's
borrowing from
no-
the finite worldview.
You're having to step into the finite worldview
Don't
to
troll.
no, it's not. I've been reading up on this while you guys have been talking.
No, I
and
mean it seriously. I was
it's-
correct when I
I-
explained it how Danny was thinking of it.
I understand what Danny's saying. What Danny's saying,
I do
agree with.
too. I understand him.
I agree with what Danny's saying. I think it's possible for someone to flip a coin forever and it always land on heads. I don't think there's any contradiction there, right? I just think what Simon's talking about is something else. And I think there's a
What?
confusion. I think it's too high level for us to understand. And I think everyone's just pissing in the wind at this point. Because if you actually
don't.
This
look
is
up,
why I wanted to ask Simon specifically. Is it true? It sounded like what Simon was saying is there is no contradiction looking at it Danny's way, but there also is no contradiction looking at it the other way. So there's no way to adjudicate
Why?
which one is like correct or something
Why
like that.
is there no infinite set?
Because it keeps going.
That doesn't make any sense.
Okay, because you're starting with two, in the case of the example I gave, you're starting with two possibilities. Okay, so although you may find yourself on what you believe to be an infinite series of ones or heads being thrown, you're never going to get to the end of that series to find out whether in fact it is a complete series.
What does that matter?
Well, because
You can't look backwards because it doesn't end.
It's conceptual. You don't have to look back.
It's not part of the example I gave. Right?
What?
Well, because I didn't give that example. I just said all, right? All patterns are going to occur within that infinite series, including the pattern, and this is where it seems contradictory, but in fact is logically possible. And maybe you're right. It seems like a contradiction to say it, but I don't think it is a contradiction for the reason I've already given. That it may appear that you're on an infinite series of ones, right? But you can't know that. You can't say, "Oh, yes, but it will occur." You could only say that it's likely to occur, right?
Listen, if we're talking about set theory, okay? Listen.
Whereas,
All permutations will occur.
Whereas
Even
when I say,
even the permutation of all ones or all heads,
yes,
and the permutation of
Look,
all
if
heads.
we're talking about set theory, if we're talking about set theory and we're talking about abstract sets, what he is saying is true. And Ray, you're right. It's probably above a lot of people's heads. But if we're talking about a physical system, which he has said we are,
How does that
then
work?
what he is saying is untrue and cannot be true.
I'll
as I
go over
say,
my
it's
set theory later.
So, Simons, can I just ask before you go to sleep? Oh,
it's hypothetical of an infinite series of head coin tosses, right? Now, yes, that physically isn't possible. So if what you're saying is a physical system, as in the real world, then
Well, no, I don't necessarily mean the real world either. I'm talking about a physical system that follows the general rules that we understand to be our universe, but infinitely. All right. Like let's just say that this universe is infinite.
My example was coin tosses, right? Do you think that?
Okay, yeah, in the abstract category of coin tosses, sure.
Okay, great. Then we're on the same page. Then I would agree with you.
Yeah.
That in what you're saying is correct. That in this physical world that you're talking about, it's not possible to have an infinite series of coin tosses.
What does that have to do with?
It's just what Vade was asking. Just don't bother with it. Can I get, before you go to bed, Silas, your vote on whether or not there is a contradiction?
No, I don't think there's a contradiction either way, particularly.
Okay.
I mean, it really depends on what you.
How you're looking at it.
Again, if we're talking about set theory, the set of all sets, all right, contains infinite sets of all types of permutations. So if we're
Yeah.
saying that this universe that we're talking about is the set of all sets, then what he's saying is true. And that should be uncontroversial. There is no contradiction. It's the set of
Does
all
it contain
sets.
itself?
Ah ha ha ha.
There's a reason set theory got rid of infinite sets, dudes.
No, it did. What are you talking about?
Mm.
So
Well,
Miller Frankel's
I
set
was
theory
upset
doesn't
about
allow
this.
for infinite sets.
I didn't like this
No.
idea of an infinite set because it seems to be bounding something when the whole point is that it's unbounded.
What gave you the idea that set theorists have put aside infinite sets?
So Miller Frankel's set theory is what most people use, that it doesn't allow for infinite sets.
Well, it actually does. In a way, it does. But
Can you
you're right.
explain?
ZFC doesn't allow for unbounded infinite sets, but it still allows for infinite sets. Believe me, trust me.
So it's okay to say it's just a matter of what theory you're using or some kind of compromise like that, right? I think I feel okay saying the way Danny looks at it, I don't see a contradiction. Maybe it's not formally correct mathematically, and maybe if you use the proper set theory, which
Helena,
means
if
you
there's
can't
no
really have an infinite set.
if there's
Oh, I didn't even know you were here, Danny.
if there's no contradiction, then then what Simus is saying is that can't be necessarily true.
Again, Danny, if he's talking from a set theoretic point of view, then there is no contradiction and it is true. But if it doesn't seem that you're conceptualizing of it from a set
My
theory point of view.
contention was the fact that Simus was saying that there was something necessary about the outcome.
Well, if you're talking about the set of all sets, then it is necessary and expected.
Now 9. You said there was a problem with the set of all sets. Does that relate to Russell's paradox or?
Yeah, so Miller Frankel
yeah.
set theory is deliberately not including infinite sets. Vade's saying that it does somehow because they're just bounded
Yeah,
infinite
because
sets. I don't know
ZFC is meant to reconcile set theory with information theory and computability problems. But it's not saying that we should always discard infinite sets for every purpose.
I thought if it's infinite, then it's not a set. It's just like a collection or some other construct.
That's kind of the way I see it intuitively, anyway.
I'm not a set theorist, but my understanding is that when we talk about an infinity of something, we're no longer talking about a set.
Simos, what's the verdict on that from you?
I would disagree and say that the only way to use infinities in this way is to view them as sets.
Okay, but can you do that within Miller Frankel? Can you explain? Because I don't
Yes,
know.
you can. I don't. Again, I don't. Where did you? First off, where did you get the idea that ZFC
Let's
doesn't
not bother
have
with
infinite
the
sets?
emotions and stuff like that
No, I
because
know it's not
we
emotions.
actually
I'm
have
just
a
wondering
real
where you got the information.
we actually have a real topic. So let's just try to stick to the
Okay,
real topic.
all right.
wait, thank
And
you.
we're now trying to include X in this topic.
No
All
passion,
right, so
Eidolon. No passion.
I like the
okay.
passion.
Look,
I'm not upset.
fine. I'll drop the rhetoric. I'll just say this, okay?
Yeah.
Again, I don't know where you're getting your information on
Wikipedia.
ZFC, but in ZFC, right, there's it's like the well, it's the axioms of the theory, and you'll go read it and just go read the axioms of ZFC, and they talk about infinite sets. It absolutely allows for infinite sets. It's one of the fucking axiomatic foundations of ZFC. But I thought you were talking about like bounded versus unbounded sets, and you're right that as my understanding is that ZFC does not allow for unbounded infinite sets. But there are fucking infinite sets in ZFC. I don't know what you mean.
Well, that surprised me.
Okay, good. Well, I'm glad we got to some kind of consensus.
I'm still confused as to why that was even brought up.
Thank you, Helena, for pointing out in a really.
People kept talking about infinite sets, and it was
You're
my
welcome.
How?
Infinite sets
No.
weren't allowed.
I'm confused as to why this even started. Something with what?
Can we pause so I can get
Said
my
or
Simon
something-
Gold Star?
Yes, you get one free dog you have.
This started with something Danny said or something Floyd said.
Something I said, I think. Danny objected to the way I put a particular
No,
phrase.
Floyd was talking about. Fuck God, it's late here, man. What uniformity of nature, and he said something. The example was something like, let's say gravity stops working for 5 seconds every 50,000 years, but it does that, right? Consistently, that peak and trough. And he says, well, that's still consistent. And then I can't remember how it got onto the dice fucking coin thing or whatever. I don't know why Floyd brought that up though.
Yeah, you're a genius, Wayne. That's exactly how I recall it as well. But yeah, again, I was the one that said the thing she was objectionable, and I think we've kind of nailed it as much as we can that we were talking at cross purposes. But that would be my impression now, having listened to Helena.
Well, that's what it seemed
Yeah,
to be
so
from the
you're of the
start.
contention then that these people weren't thinking in a set theoretic point of view, and you were, and that was the disconnect.
I think so. Yeah, I think you kind of hammered it
I
out.
still don't.
It seemed to be from the beginning that Danny was talking. Look, I got Danny's point, and it's still Danny's point doesn't. It seems right, right? I think it was just. I think Danny's
I still
talking.
don't think it's relevant. We're talking about one set.
Well, if the one set we're talking about is the set of all sets,
We're talking about a set of coin flips.
You mean a
set of
subset?
outcomes of.
You're talking
No,
about a subset of coin
no,
flips.
we're talking about a set of the outcome of coin flips.
Yeah, my impression was that there was one infinite set of events. Okay, so that's to say, I roll a dice an infinite number of times. This is sequential, one set, right? Okay. Now, from what I contested was that this is the claim that I contested. The claim was that in virtue of it being infinite, that there would be all outcomes would, or all permutations would occur. And then he attached necessity to that. Like that was true. That's to say that if it had to be that way, which means that there must be a contradiction in saying that that there would only be one permutation for that set in that world.
Yeah, well, so Danny was taking him to have meant that all infinite sets contain all probable outcomes, which is not true even from a set theoretic point of view. But if you're talking about the set of all sets, then it is true. If you're talking about an unbounded infinite series, or an unbounded infinite set, I'm sorry, then yes.
Yeah, that is.
It is.
I think the nub of the contradiction, or the nub of the disagreement. And I think, yeah, again, we were just I was perhaps using loose language, so I apologize if that was the case. But I think we've got there eventually anyway.
Did we?
All right, so now we're on all the same page from a set theoretic point of view. Let me tell you why set theory is bull.
Well, maybe we could go on with the whole reason why. So I think we all are agreeing to concede that in fact the way Danny's looking at it, there really is no contradiction. So now, if everyone agrees that we agree, I'd like to kind of know what the whole point was.
Well, it's not that Danny had a contradiction.
Well,
Danny thought I had a contradiction.
Well, the thing is that
I think we've agreed that
you said that there could be you said that there could be something you said there could be a probable state of affairs that's necessary. That's contradictory, in my view, because to say something is probable indicates that either possibility of it happening or not it's that it happening or not happening is a possibility. To say something that's necessary, that means that there's some kind of impossibility or contradiction, at least in the logical sense, right? Set aside physical and metaphysical possibility. But yeah, think about it. This is the way we can show it, right? This is the way we can show it. If I said, wouldn't it be really silly for me to say, is it probable that the law of identity is true in this world? That is silly because we just conceive the law of identity as being necessary, true of all worlds. Right? There's no probabilistic aspect to whether it's true that the law of identity holds in this world, right? It's not probabilistic. Probability only really relates to the question of whether the actual world is more probably one state of affairs as opposed to a different state of affairs.
Hmm? Did we lose everybody?
No, I mean, I don't think anyone's. We've kind of hashed it round enough.
Simon, what do you know about pi?
Who was the person that said set theory was bullshit? I'd like to hear why. That would be
Fade.
good. Not that I disagree, but
I think you're going to need another 2 hours for the person that said that to hash it out with you. Can
We're
we
gonna
just
need
all
a
agree
bigger
that?
boat.
Can we all just?
whoever
we
it is, we'll have a hangout with Hogtie and we'll thrash it out.
It was Vade. I think Ix, whatever. Can we just all agree that I think Danny was right to I know Concrete got a bit annoyed, but when there are people like Concrete and
No, we
Tasteless in
don't
the
need to
room,
have this talk,
no, but what
Ray.
I mean is that would have ruined tonight. And although people got a bit pissy, right? We enjoyed quite a placid time when we haven't just had fucking noise trolls coming in here, and we need to be like that more. We need to moderate them more. These people that just come in and just try and piss over everyone. Fair enough, Danny and Simon might argue, but they're not going to start pissing on each other. You know what I mean? That would have ruined it tonight.
And I do want to, if Simon, if I offended you, I want to apologize. I don't mean, well, I did mean, if I offended you, I did mean to offend you, but I think that was something that regrettable. That would be something regrettable retrospectively.
It's not a problem, Danny. I appreciate the passionate debate. And I would definitely look up whatever it is, Zermel or Frankel theory. I can't remember the name of it now, but I did that.
What are you gonna look up? What are you gonna?
Zermel Frankel set theory.
Oh, okay. I actually don't know a lot about set theory. I mean, I know I read about Russell's paradox a long time ago, and that was like it. Like when it comes to math and like symbolic logic and all that stuff, I'm just at a loss. And like quantum theory, I mean, I need someone to teach me quantum theory. I don't know anything about quantum theory.
But you seem to have a good grasp on the logic, and I'm not trying to have a go at you saying that what you're saying is illogical.
Well, these are well, there's like logic, there's like meta logic, which I don't know anything about, like symbolic logic and like Russell's work and Cantor and all of the out of the all of the lot. I don't really know y'all.
Cantor.
Cantor, is that how you say it? And all of them, like I don't know Hilbert, and I just don't know anything about them. And but I think that we use these notions that they produce, like necessity and possibility and probability in metaphysics. And there we have to have a really solid understanding of possibility, probability, necessity, contingency, all these things when we're doing metaphysics. And that I feel like I have a grasp on, but like all that other stuff.
Again, I'm not trying to disparage.
No, I know you know.
I think the way I said it was meant to be kind of jarring because it's not intuitional what I was saying, right? But then neither is set theory or this open bound set theory, which I'm talking about. It's not supposed to be, easily accessible. It is supposed to be abstract and not intuitional, just like.
Yeah, it's very esoteric as well. So it's just very so not a lot of people can participate.
We seem to stretch through it, and again, I appreciate Helena really trying to get in the middle of it and understand both sides, because it's given me a better way to express it in the future anyway. So.
Thank you, Simon.
You know how Helena might have been a good referee is that everyone was mad at her.
I wasn't.
No, I don't think anybody was mad at me. Well, maybe you were mad at me, Danny, but I thought I expressed the way you were saying it. I think I did a damn good job. I got both sides to understand the other side. Well, Jack, that's just a given. Jack, he likes to do that.
I think any moderator who's willing to make Jack mad at them is a good moderator.
I think Jack has fun. Jack has fun doing that.
Yeah, I appreciate.
I don't think that was fun for me or Jack. I don't. I think if you think frustration is a form of enjoyment, then
yeah, it's fun for Jack. It's not fun in the moment, but when it's over, it's extra fun.
Are you kidding me, Helena? You got it.
No. That's really right. No, that's right.
Off about it.
There you go. See what I mean? But what's so hilarious is that Jack, so cogently, in 2 sentences, explains it all, and then he keeps repeating, And I got frustrated. I'm like, we get it. Can I? Because I'm holding on to what you said. I need to hold it in my head so I can see the other side. And so I'm going, we get it, we get it. And then
Wait,
Jack
but
goes, Jack
Helena.
goes, well, let me finish. And Jack goes, what do you bet? People didn't understand. And I go, yeah. Shut up, Jack. Okay, Simos, is there a contradiction or not? And Simos goes, actually, I didn't understand.
I've got to be honest.
Wait, I want to know. I want you to describe your exact feelings at the moment when Simon says, "I need to listen to Jack." How did you feel like at that moment? Like, were you?
I felt like, holy shit, no. I felt like, holy shit, Simos, what have you been doing? He explained it 9 times in a row. That's what I felt.
And
Yeah,
then he
but
said, explain it one more time.
Jack tried to explain
But
quite a few
that-
things similar in the past, right? Especially philosophical things. And I'm a bit slow when it comes to understanding deep philosophical ideas. So that's why I was thinking, well, maybe I'm missing something. So if he says it again, perhaps I'll understand it the next time he says it.
No, so I won't start bugging Jack till he has screamed it 10 times.
Yeah,
Then I'll say, we get it, we get it.
That's kind of how I feel.
Actually, I'm very repetitive myself. I actually repeat myself all the time. But it actually works like when I'm teaching like 13-year-olds.
You just did it right there. You said,
oh no.
Very repetitive. I repeat myself a lot.
Myself, I repeat myself all the time. That's what you just did there, Danny.
I know.
Yeah, that's bound to happen.
I think he didn't understand what Jack was saying because they were still not sharing the same foundational rationale from a theory perspective of what they were even addressing.
It's something related. If you take an irrational number, say pi, or maybe pi is a bad example, but something that's non-repeating for ever, it's infinite, correct?
Wait, non-repeating? Oh, like not like an infinite number of twos. Like, yeah.
Rational number.
We don't know for certain, but that's the idea, is that it is.
Oh, fuck.
But it's true, we don't know for certain. You can say, oh, fuck, but that's right.
No, it's proved.
Oh, what?
It's not.
Yeah.
Wow,
That's proved.
So it's
No, actually,
it's just an
technically,
example.
no.
Oh, fuck.
JJ,
All this
Okay,
doesn't
but I
matter.
want to hear
definition
about
of
the
a
proof.
rational number is that it's not rational, which is the division of two integers. So there are arguably, I mean, maybe very large numbers. Well, I don't know. Maybe it could be all of them. But yeah, the whole idea is that it's not a division of two integers. That's a definition of an irrational number.
Yeah, go ahead, Jack.
Yeah, Jack, how was it proved?
I don't know. You'll have to ask.
Sorry, ask it.
Did you say you'll have to ask David?
Alex Malpass or
Oh, fuck.
or Jim.
Right, okay. I will do so in the future, for sure.
So it
Ace,
goes
what I
on forever.
jumped in earlier. Ace, you could have cleared this all up very
Oh,
simply.
Jesus.
Ace could have just jumped in. One of the
Oh,
top
yeah.
mathematicians
Well, I
on
mean,
the
I did
server.
translate that equation into English. It's pretty simple.
Posting that. Oh, it's
Yeah,
still there.
Ace was busting out that equation that was just gobbledygook to everyone else, and Ace actually got it right.
All right. So
I
the
mean,
point
it's
is,
pretty basic.
Oh, fuck.
Hear that?
How
Basic to
it is.
Ace. Ace, you could have cleared this all up.
Well,
Just tell us how
I mean,
basic
I
it
also
is.
said I'm not a
That's
big
what you
fan of
said about
infinite
Dio
sets.
running a mile in 7 minutes.
Yeah, I know. Well, running, I mean, I can do that easily. I'm not saying Dio could.
Oh, you could do that easily now?
Yeah.
Oh, you want to bet?
I'm getting
Yeah,
my
hell
60
yeah.
Gs.
Like, you can just run 7 miles, no problem. 7-mile minute,
Dude,
no problem.
I used to run sub 7-minute miles 4 miles.
Oh, so
Not just one sub 7-minute mile.
So you'll record yourself running a mile 7
Look,
minutes. No problem.
look, we were fucking talking about mathematics. Get the fuck out of this discussion.
So you won't do that, is what you're saying?
No, I'm not fucking
Oh,
interested.
so you can't do it, okay.
You're a fucking retard. God damn, Johan.
Oh, God, no, we'd be awake for another fucking hour. You bastards. Oh, my God.
Aww.
So I was actually thinking about this the other day, and I was thinking about pi or something similar. something where the numbers go on forever, infinitely, presumably. And is there a sequence where there are 8 million, whatever number of ones in a row, in integer?
Yeah. Yeah.
Right?
I mean, any of the irrational transcendental numbers would qualify.
No. He's talking about a number that's a million ones after 0. Yeah, you could definitely generate that.
Well, I'm thinking of something. No, I'm thinking of something like pi.
He's talking about in the case of pi. Just use pi. Use the case of pi.
I don't know.
Are you talking about an irrational number?
Well, yeah. Look, the
Oh,
pi
fuck!
pi cannot be defined as the division of 2 integers.
Give a shit.
Which is what makes it transcendental, or that the case that it is
Irrational.
This is irrelevant.
Oh, right. Yeah, irrational. Yeah.
It's completely irrelevant.
Not really, because it's to do with infinities or the type of infinity. Irrational numbers have a particular
Yeah,
type.
pi is just a metaphor here.
Well, so you're asking, can you generate a finite number of single digits?
No.
You're saying an infinite. You're saying an
No.
infinite number.
No.
What are you saying then, retard?
I'm saying it goes on forever, right?
Yeah. Well, theoretically.
And there's no way to discern, well, other than calculate it, what the sequence of numbers are. Is it possible that there is a sequence of pi somewhere along the line that's, 8 2s in a row, or 100 ones in a row? Maybe it's some other one of these numbers.
Well, the case of pi being irrational and transcendental is that every finite series of numbers
Doesn't
is
matter if
contained
it's pi
within.
or not. Okay,
Well,
that's okay. Go ahead.
Yeah.
That's actually what I guess what I was thinking, because I didn't know
Yes,
much about pi.
that's the case. If you can think of any finite series of numbers that exists in pi.
So maybe all permutations,
Is that necessary?
except
JJ,
for
you're retarded.
infinite ones.
Yeah, except for infinite ones, yeah.
This is just something I was thinking of a couple days ago.
Yeah, probably
It's
because that's the
interesting.
case that I gave for the reconciliation of probabilities under Bayes' theorem, where you can develop finite sets over an infinite set, and the development of rational priors on probabilities will fall flat.
Did you do this?
I thought you heard that. It was when Cam was giving his whole thing about the urns and red balls and things.
You've already done this, Fred?
Oh.
Yeah.
Fuck me, nice one.
I don't know if I heard that though. Maybe that's where I got it.
Okay, so if we're using Bayes' theorem to develop a probabilistic model of outcomes, that only works if we assume that the series is infinite and it contains, all permutations of the system equiprobably. But if it could be said that we're in a universe with a finite number of outcomes, then it could be the case, like in the case given with pi, that all finite series of numbers are contained within pi. That we could take some finite segment of an infinite set of outcomes, and using Bayes' theorem, the probability of the Monty Hall problem could just resolve to literally be 50-50. Because we could be in a universe, we could be in a universe where there are a finite number of outcomes, and they are always that the red ball that you chose came from the urn that is 50% white and 50% red.
Yeah, I don't think I heard you talking about pi, but
Well,
that's
I
what I
mentioned
was
pi
thinking of, is that it contains all finite permutations.
Yeah, all finite permutations, right? So, like, the reason that I brought up pi is that, like, if you're wagering like on a like a distribution of coin flips, okay, and you can I brought up pi just conceptually, okay? I wasn't trying to reason on pi as far as probabilities go. But if you imagine an infinite number of coin flips, probabilistically speaking, there's going to be some near infinite number of coin flips that are of a single outcome, either all heads or all tails. And since, as we understand physical universes, they are not infinite, you could just happen to end up in a physical universe where it doesn't matter how many times you flip that fucking coin, it is always going to come up tails.
Again, that physical universe thing is irrelevant to this. I think
It's not irrelevant.
and I think
because
that's
we're talking about Bayes' theorem.
I think that's what Simon wanted to say with the coin flips is that finite permutations are all finite combinations. Which
No,
seems
he was
silly.
saying in an infinite set you can have simultaneous infinite sets of contradictory outcomes. And if you're talking about the set of all sets, that is in fact true.
But you're not talking about the set of all sets.
Right, we're not talking about the set of all sets. We're talking about infinite sets
You're
of a
talking
single
about an
outcome.
infinite set of coin flips.
Well, in an infinite set of coin flips where there's a binary outcome, right?
Right.
If you're in some segment of that infinite set, like if you just happen to be in a universe, that is finite, you could just end up in a universe where the actual probability, okay, the actual probability of a coin flip is 100% tails, and it could still be a fair coin.
That is incorrect, man. Because what you're missing is what determines the permutations. That's the key aspect. So, if the permutations are determined by a probability of 50%, then you're the way, even if you want to phrase it the way you do, it's not going to be likely. Why? Because it is not. It is determined by the probability.
Yeah, it's very unlikely. It's extraordinarily unlikely. But you could still find yourself in a universe that just happens to be on some segment of that infinite chain of 50% probabilities where a perfectly fair coin always comes up tails for the entire life of that universe.
That goes against the same probabilities, dude.
No, it isn't.
It goes against the same probabilities that the outcome is determined by.
How does it go against?
So in this case, the 50% is determining, the probability of the permutations.
Okay.
Do you know what I mean?
Tasteless. Let's look at it like this, okay? We have an infinite series of heads or tails coin flips, right? Now, do you suppose that there is a series of 100 results that are purely tails? Oh, fuck. Wow, this is a hard question.
Could I just interrupt and speak to JJ for a brief second?
Please.
Yeah. Okay, JJ. I think it's Vade, isn't it? Really did make the point there when he said near infinite, and the reason
which is finite.
Which is finite, and the reason I was saying that it could be infinite is because we weren't stopping the infinite chain. Okay, that is to say, from Danny's point of view, he's correct because he's saying, well, it's an infinite chain that you're talking about. But of course, I was saying in order to know it's an infinite chain, you would have to stop it, and then it would become finite. And so that's where the disagreement really.
It's defined as an infinite chain.
That's exactly what I said at the very beginning.
Irrelevant because it's defined as an infinite chain.
I'm
and that's what
very,
I
very
addressed when I
happy
said,
about that.
Are you talking about a computability problem? Because if you're talking about a computability problem, you are correct. But if you're talking about abstract infinities, that doesn't even factor in.
Exactly, and I was actually talking about the abstract infinity when Danny made that particular point, because I was saying, well, look, it's either an abstract infinity or you're making it finite by saying, look, it's a very long causal chain of events. Right?
Well, so it seems there's still some confusion.
No.
No, there's no confusion. Dude, you said it perfectly that time, right? You really did. You nailed it. So I don't think there's any confusion. JJ, I hope you understand why I was making those two distinctions.
Nailed it.
No, you're saying that Danny's making it a finite set.
No, I was saying Danny was making it an infinite set, in which case I was making it the set of all sets. right? And I was saying if you were to put it the way Danny puts it, he's talking about an infinite set of sets, so I think he's wrong for that reason. And then I
What?
actually was talking about what Vade just talked about when I first stated the issue, right? Which was to say, look, if you want to know that it's a series of events, right, then of course that makes it finite. That's part of the hypothetical definition of what I was saying, right? So that's when
You're saying it makes the superset finite. I see what you're saying. Okay.
Indeed, yeah, because you have to know that it's that long, you know, and which puts a
Why
finite number on
would you have to know that?
it. Because you couldn't count an infinite number.
We're not talking about actually counting.
Well, we are because we were talking about any sequence, and that
my
within that sequence is, of course, a finite number.
you-
Know that it's a sequence. It
It's
must be a
completely
finite number.
conceptual. You don't have to count them.
Yeah, you do. If you want to know
Oh
this,
my goodness.
if you want to know that it's a sequence, then you do, in fact, have to count it.
I might go for maybe having like something that's a sequence, having a consecutive order, but not for all infinities.
It's ridiculous.
Well, no, it's one or the other, right? That's all I'm saying. If you're not going to count it, right, then you're talking about what the set of all sets, right? Because that's the only way you could include an infinite number of anything, right? To be less than another number of infinite anything, right? You'd have to be talking about a higher R's number, right? To start with.
I don't know how that relates to flipping a coin an infinite number of times.
Well, I'm saying within an infinite number of coin tosses, okay? Then
Yep. Yep. Go on. Did he drop out again?
I think so. I think he's giggling. Something's going on over on his side. Simon, you have to start over. Within
Within
Sorry
an
about
infinite
my
within an
number of
infinite
flips.
sequence, yeah.
Yeah, so I'm just saying, look, I think we've been around it, and I was just pointing out that they really said it very accurately.
No. Oh
What do you mean, no?
You are
No. Okay, can you count an infinite number of anything?
Yes.
Okay, how do you do that?
Yes. Start with one.
One is not an infinite number.
It's irrelevant.
No, I don't think it is.
Okay, so I think we need to make a distinction here. So you can define a procedure to count an infinite number of things, but that doesn't mean that you have an infinite number of resources to be able to accomplish that procedure.
Who needs resources?
It's not from lack of resources. It's because it doesn't end.
Indeed, yeah, and therefore it's not a sequence held within by itself. You can't say this is the first number and this is the last number of the sequence.
Well, if you had an
That's what I
infinite
said
amount of
when I talked
resources
about
to
outcomes.
count,
Yes,
it would be
you're right.
irrelevant that it doesn't end.
I mean,
That's the
again, you
point.
said it. I just thought that Vade said it really accurately when he talked about near infinite number.
Mm-hmm. That's what I was trying to do when I couldn't think of the right words. I was saying approaching, and tangents, right? So it's easy to get to mix those two viewpoints into one viewpoint, and then you get messed up, I think.
Got to appeal to Ace here.
Don't do it, JJ.
What's up?
I'm doing it. If you flip a coin an infinite number of times.
Don't say could it end up, blah blah blah.
Wait, sorry, say that again?
If you flip a coin infinite number of times, Simon wants to say mutations will occur. All sequences of heads and tails. I'm not even sure this is a really good example.
They have to
Yeah, I
occur
don't
because
think
it
that
keeps
there's a
going and going
necessity
and
proof.
going.
I
That's
don't
the
think that there's
idea.
a necessity proof there. There's a probability proof, and
Oh, fuck.
Vade made a good.
What does probability have to do with it?
Like I said, I don't. So there's no way that you could construct a proof, I think, for this infinite series that it will because that's an infinite proof essentially. But you can make a probabilistic assessment of the matter.
Yeah, proof might be a strong word here. I was talking about it being definitional, really.
Yeah, I mean, you can kind of define like that the probability approaches one, but like I said, I don't think you can do anything better than a probabilistic
Well, I think it
approach.
sums to one, in fact. Probability-wise, that is.
I almost don't care anymore.
That's not true though, because you could hypothetically flip a coin an infinite number of times and get tails every single fucking flip. It's possible.
That's true.
The probability is insane, but it is fucking possible. So no, it is not guaranteed to express every possible sequence.
Oh, so you're
it
saying
could all...
that? So you're saying that you may not
That's
get
actually
the
a really
permutation
good counterexample.
where you get a tails and a heads in a row? Is that what you're saying?
No, because the only finite subsequence that you'll have is a finite sequence of tails. You won't have any
Right.
of
But
the
it will be
space.
finite. That's the point.
No, you could do that for infinity and just never land on heads. There's no guarantee in the coin flip that you're going to ever get heads. Certainly, there's no guarantee that you're going to get 483 heads and then 364 tails.
Yeah, that's a
which is
great
what he's talking about. Which is what he's talking about. There is no guarantee that that would happen even in an infinite number of flips.
It's not a sequence.
It's just very probable that it would.
Yeah,
Not
that's
a
exactly
sequence then?
Yeah, that would be my best guess. It's not a sequence.
I mean, it's
We
not a
wouldn't know
sequence.
because you haven't got to the end of it to know what the sequence is.
What?
Because you haven't got to the end of it to know that that is in fact the sequence.
What sequence?
You're literally borrowing from the finite worldview.
Fuck off.
Yeah, and if you're doing that,
Oh my goodness.
Hey, Helena.
I know what you mean.
Yeah.
Fuck. Nice.
Oh, dude.
This is hurting my brain at this point.
It's not intuitional, so don't try and use intuition to get it.
No, there's no.
But it's not a sequence, right? If you're saying that I have this infinite number of things, okay, well, that's not a sequence until you found out what the last one is to know what the sequence is. How
So
would you
all
know
sequences, you're just saying that all sequences are finite.
Essentially, that's part of the depth. Yes, I would say so.
Okay. See, there's a problem. So if you flip a coin an infinite number of times, you want to say that all possible sequences of flips,
which are finite. This is near infinite. Would be good, but finite is definitely the word to use.
Finite is the word.
Yep.
Will occur.
Will occur. Yeah.
Oh. Unless
that's purely a probabilistic claim. It's possible that they won't.
Unless you flip all ones or all heads.
Yeah, but it's infinite, so you'd still be flipping them, and therefore you wouldn't know whether you're going to flip all ones.
That's fine.
You can't think of there being an outcome.
Unless
but
infinity doesn't have an end. There's no end of infinity.
Yeah, it could be an endless series of heads or an endless series of tails with no other permutation ever manifesting. That's the fucking point. It would still be infinite.
Right. The problem
you
is
just wouldn't
then,
know about it.
When I say accept the sequence of flipping all heads, which is an infinite amount, right? And if it's infinite, it's not a sequence. That's what he wants to say, which shit.
Aww.
I don't think that's necessarily true. I don't think you can say that there's no such thing as an infinite sequence.
Yeah, and I think that this now we have to talk about like any possible sequence or any particular sequence. So you could argue that if you have all possible sequences of heads and tails, then sure you can get any finite sequence. But if you only have one single sequence, it's very likely that you won't have all finite subsequences ever. Maybe.
Who knows?
The probability is 50-50.
How did you put probability on it?
Some probabilities are much worse.
Why is a sequence finite in this definition?
Because the question is can you get all finite sequences from a series of infinite flips?
Sequence is finite in this definition because it's very convenient for Simons.
Well, really, because you'd have to, in order to know what the sequence is, it has to be finite because it has to be countable. We're talking probability.
That's saying that a sequenceness is dependent on your knowledge of it, which I don't think is necessarily.
Your knowledge is complete. Yeah, you'd have to complete the sequence.
So he's just discounting a sequence of infinite heads as a sequence. That's the biggest problem here.
It's just not necessarily entailed in an infinite set.
In what kind of infinite set?
In any infinite set, it is not necessarily entailed that all permutations will be valid. It's very likely.
When you think like
that
that,
all permutations will be validated, but it's not.
when you think like that, let me just say this: when you think about it like that, maybe you don't think you are because it feels like you're not, but really you are imagining an end, right? But the point is, it
No,
never
I'm really
ends.
not. Let me give you an example. Okay, you're saying I'm imagining an end, and that's why I'm wrong, right?
I'm saying you're sort of going, well, the outcome would be, at the end of it, we would see, right, all there would be, all of them, all right, all of those words